Alright guys, welcome back to Mr. Brecklin's Help Spot. So here we are dealing with imaginary units. We have imaginary units because not all quadratic functions have real solutions. And so what we're going to do is learn to deal with those situations when they arise. As we see here, we have a definition that the square root of -1 is equal to I. Okay? So if the square root of -1 is equal to I, by definition then, I squared is equal to -1, all right? The square root of 9 is equal to 3, then 3 squared should get us back to 9. So it's just following the pattern of radicals that we already know and love. What can we do with I? Well, it's an imaginary unit, but it behaves just like any other number, so we can perform all the functions that we do with numbers: add, subtract, multiply, divide, square, square root, the whole 9 yards. So what we're going to do is just practice some addition. So addition and subtraction, same difference. And what we're going to do is handle a simple problem like this. The first thing I notice is that I have parentheses. When I see parentheses, I think distribution. And so what I need to distribute to this first set of parentheses is a +1. And a +1 times all of this stuff is all of this stuff. 8 plus 20i. The second set of parentheses here has a -1 distributed through. I've also used the lingo or the jingle in class, draw the line, change the signs. So as I change that to addition, what happens is a negative times a negative becomes a positive. A negative times a positive is a negative. And the numbers stay the same. Or, like I said in class, draw the line, change the signs, and we got a +7 and a -12. The rest of this is simple, combining like terms. 8 and 7 give me a 15, and 20i and a -12i give me a +8i. Okay? Moving on. Okay, so now what we have here is multiplication of imaginary numbers. And as you can guess, looking at the scenario we have here, it's a binomial times a binomial. If I had a monomial times a binomial, I would use the art of simple distribution. When I have a setup like this, I'm going to follow the pattern of FOIL. First, outer, inner, last. And we're just going to take this a step at a time. 5 times a -4 is -20. And then we go to our outer terms, and we got 5 times a -3. That's a +5, so that's going to be a -15i. And then a -7i times a -4 is going to be a +28i. And then lastly, our last terms, -7i times -3 is a +21i squared. Okay, so what we have here, we have our real number out front, -20, stands alone. And then we have these two like terms right here will combine, so a +28 and a 15 have a difference of a +13i. And then on the end here we have our imaginary to the second power, 21i squared. But taking into consideration that we said in the first part of this video that I squared is equal to -1, and this 21 and I squared is attached by multiplication. So that's going to be 21 times -1, which is essentially -21. So this -21 and -20 are going to combine to be a -41, and my +13i just drops right down. So our last situation here is we have our imaginary fraction, and we don't like irrational numbers, or imaginary numbers for that sake, in the denominator. So we're going to use a very similar method of complex conjugate to get rid of that 3i, or that -3i in the denominator. So just like we would approach it with the complex conjugate and radicals, we would say 2 plus something. Well, the 2 plus something here is 2 plus 3i. So I'm going to multiply by 2 plus 3i and 2 plus 3i on top and bottom. And so I'm multiplying, which makes my world pretty easy. or at least not very complicated. All right, I wouldn't say it's easy, but again, we're bumping into the concept of FOIL, which hopefully we're pretty comfortable with, and we just want to make sure that we don't make any mistakes. I'm hoping I haven't made any mistakes in the video so far. So we go through the FOIL, and we have 7 times 2 is 14, and 7 times positive 3i is positive 21i. 4i times 2 is positive 8i, and 4 times 3, or 4i times 3i is positive 12i squared. All over the bottom part. Now remember, in the bottom part, there should be some interesting cancellation going on. Not necessarily going to happen on the top, but it should happen on the bottom. When we're done combining the terms on the bottom, we should not have any more i's. So we got 2 times 2 is 4, and 2 times positive 3i, positive 6i. And negative 3i times 2 is negative 6i. And negative 3 times positive 3 is a negative 9i squared. Now we just want to take into consideration again that these I squareds are both valued at negative 1. So that's going to be 14, 21i, and 8i is going to be a positive 29i, plus 12 times negative 1, all over. 4, cancel the 6's, minus 9 times negative 1. That makes this a negative 12, and 14 minus 12 is 2, plus 29i on the top, and 4 plus 9, because negative 9 times negative 1 is a positive, and 4 plus 9 is 13. So our final answer, 2 plus 29i over 13. And before I walk away from this problem, the last thing I want to check is that 2, 29, and 13, do they have any common factors? If they do, I can reduce this whole fraction. And that's how you rationalize imaginary numbers.